Alright, so this is on the LC circuit. Now, what happens is the question basically says that at time equal to 0, there is charge Q naught on capacitor and the switch is opened, and just at t equal to 0, it's closed. So the circuit will be complete. Now, what happens is, look, the current is dependent on charge on capacitor, right? And the charge on the capacitor is dependent on current, as it is dq by dt is I and all. So they are both dependent on each other, which makes it a special case, and that is feedback system. Now, in general case or a general instant, we assume current I to be flowing this way to solve the feedback system. Now, this I is directed towards that, so uh, and at the general instant the charge should be Q, not Q naught. And now, wait a second. Now we have to solve this. So we have to write two equations. Firstly will be I equals dq by dt. The reason is quite simple, as the rate of increment of q is directly proportional to I, and Kirchhoff's law, I mean, we have to just go through this path and check the uh, voltage potential difference, and from this path we have to check the potential difference, and it should be same. The potential difference across the capacitor is just Q by C, and that should be equal to minus L di by dt. Now, why minus here? The reason is quite simple, because the current is going in opposite direction. Now we have this equation. Now we have to put I here, and after putting I here, we'll get the double differential of charge, which is d square q by d t squared. Now look, we can clearly see this is an SHM equation. So relating with SHM equation, which says A equals minus omega squared x. Its solution is sine x equal to, this equation's solution is x equals to a sine omega t plus phi, and this phi and a is unknown, but we should know it. So this will give us something looking like q. Firstly, we have to make it look good. To make it look good, I'm going to do here d square q by dt squared equal to minus of 1 by LC. Now root and squared, because there is omega square, and actually turns out this is the real omega we used to denote omega, and then x. Instead of x we have q here. Now we have everything, we just need to generalize, which is q is a sine omega t plus phi, and then this is our equation where omega equals 1 by root LC, and now to find the value of A and omega, we'll need to solve this. Now here are some tricks. We knew that at time equal to 0, charge was q naught. So now at time equals 0, q naught on capacitor. So now we will just put t equal to 0 and q naught equals a sine phi, because the omega t became 0 as t is 0. Let me write this properly. Alright, and for the other equation, differentiate this equation, equation 1, differentiate 1. On differentiating 1, we would get something like dq by dt is I, and 1 with respect to t. Now we get I equals a omega, because of chain rule, and then cos omega t plus phi a omega, and then this. Now we know at t equal to 0, I is 0. The reason being, as change of current can't be sudden, through short form, can't be sudden through L or inductor. That's it. Now at t equal to 0, we will get cos phi. So I is 0 at this. So cos phi should be 0. If a omega is 0, it won't work, because then the amplitude, the function would get 0. So cos phi has to be 0. For cos phi to be 0, phi should be pi by 2. Now I know in general it could be minus pi by 2 or 3 pi by 2, whatever, but let's take this. Now coming to the next page, we have everything. We can just use phi equals pi by 2 and put it here. We will get sine pi by 2, which is 1. A is q naught, so we can write the general equation for q, which is a and a is q naught, we found out, sine omega t. Omega is root LC, so t by root LC plus pi by 2. That's it. That's our equation of q, which is the charge on the capacitor as a function of time. Now for the current, we can differentiate this. With respect to time, and we will get I. This q naught by root LC cos That's it. Thanks for watching. Hope this helped.